Okay, guys, so welcome to the third class. This is actually the second class on the Swift primer. Last class, we talked about the constructs Swift offer to us in order to create symbols, both for values and for types. So, as a quick reminder, we have lets and bars for creating values, but we also have enums, structs, and classes to create our custom types. So all of those have their own capabilities and behaviors, and the idea is to leverage them as much as possible whenever we find them fit for our needs. So for this third class, we are going to start talk about the existing data types that actually we didn't cover so much last class. Then we'll talk about how to make our apps have a functionality, a behavior with functions. And then we will also explore how to use common existing functions that Foundation, this framework that we always import, offer for us when we are using Swift. And finally, we will explore a little bit of what the computed properties are. So let's start with the existing type. So um, last class we mentioned some of them. We have the strings, which allows us to represent basically collections of characters to represent text. And then we have dates. We can also, of course, use our own. But when it comes to data type, there's actually a few more that we can um, reference here. For example, what about if we want to determine whether this employee is a contractor or not? So we will create a property, possibly a var, because that could change. And this is actually a Boolean. A Boolean is just a bool in Swift. Of course, it will break my initializer because I'm relying on the automatic initializer for this type. So I will have to also provide the is constructor here. So remember, the initializers are automatically created for us when we use structs. So whatever property we determine is part of the struct, we will also have to use it on the initializer here. So let's say, okay, this is a contractor. Yeah, let's say yes. And then what about years in company? It's actually the most common type, which we didn't use last time. And this is an integer. Um, this is interesting because we could actually reference this in a different way and have it be have it become a date of start instead, and then calculate that. But that's going to be a refactor that we will do later in this class in order to understand what computed properties are about. So let's leave this as a regular property instead, and let's say this is like one. So these are the most common data types: the integers, the booleans, the strings, the dates. There's also another one that is usually not very common in other languages, but it's actually very common here, which is a way to reference IDs. We have the type UUID, which stands for Unique Universal Identifier. You may have used it before, but this is actually very used in Swift. So this is a regular UUID, and we can actually have it become something, a random universal unique identifier right from the beginning. So that way we don't have to provide it on the initializer because we set up first value right within the struct. So, okay, these are the first part I wanted to finish covering from last class. And then let's jump onto functions. So functions are basically a way to have all these nice and pretty structure that we have been creating have some functionality, have it change over time to provide certain value to users. So let's go with start writing some functions. Functions can usually be part of other types, like for example, classes or structs or even enums. But we can also create them everywhere, like globally. We can say, okay, we want to create a function that greets. We just use the keyword func. We say a name. These parentheses mean we are not taking parameters, meaning we don't have any input. And basically, these brackets will open the context of the body that defines what the function will do for us. So basically, that's what functions are. I'm sure you guys are already familiar with it. And basically, we can say, okay, hello, because this is just a function for grading. So that's all it does. And this is a global function, but usually that's not a great practice. Not that it's impossible, like there may be some cases where you may want to create global functions just because the scope is very open. But most of the cases, you will actually make them part of other types. Structs and classes are the most common places to put functions, but actually in Swift, since enums are so well developed, you can also create functions here. Like for example, I can create a function that says position name returns string. And in this case, I can actually use a switch. This is actually a control structure that we'll be talking about later. But we can say, okay, let's switch over self, which is the enumeration. And if it's a developer, we can return developer, let's say, a developer. And we can say a default for a chief officer, so that it returns the chief officer for any other case. So this is actually a function that is leveraging whatever the self enumeration has to offer. And that way it will return a string depending on the case that it applies to. So that's it. Structs are actually in our place. It's actually very similar to classes, where we can just place functions and have them provide certain behavior. In this case, for example, we can provide a wrapper for this position name. So we can say, okay, position name. We want to return the position dot position name. So we are starting to use the dot operator. The dot operator, of course, as you may be already familiar with, is just a way to access inner members of certain instance. In this case, we have an instance of the enumeration position, hence we can access the function that we just created. So this is actually poorly named because functions should usually have verb names. So this should actually be something like resolve or get position name, something like that. So use that in here and in here. So it's actually a very good practice to name correctly the functions you create in functions, since they try to represent blocks of actions. You want to name them starting with verbs. There may be certain exceptions, but if those exceptions are common, maybe you should consider using another structure, like another construct like computer properties, because you may just be creating something that really doesn't leverage the full spectrum of the capabilities of what the function has to offer. So, okay, let's go back to classes. Classes are the most important ones and actually are the probably the main users of functions. I have a few examples here. So what about if we create a function that will filter all the employees within this array that have the flag is contractor as true. So we just want to return all the employees that are actually contractors. So let's write a function that says, okay, filter contractors, or just get contractors. The filter will actually happen inside. This will return, of course, an array. We will use the shorthand for array and say an array of employees. And what we can actually do here is iterate across all the contractors and say, okay, if this employee is contractor, we will return it, we will add it to the resulting array. Otherwise, we just leave it behind. So we can say, we can use the structure for in. So we can say for employee in employees. So what this does is we are iterating each of the employees within the array employees that we have access to in here, because it's a property within the class. And we can say, okay, we have a variable that we hold the resulting contractors. So we say contractors will start as an empty array of employees. And every single time, if I find this employee I'm iterating over is a contractor, I can add to the contractors array. It should be contractors because it's an array, so it should be pure. And say contractors dot append. We append the employee that we already verified. It's actually a contractor. At the end, what we do is just return the resulting final array of contractors. And we already completed a piece of functionality that will allow us to filter all the employees that are actually contractors. So this is just an example of filtering. Basically, this is what we're doing here, filtering. Now, we will do something very similar, just filtering operation, but in this case, we will just not say whether this is a contractor or not, but we actually will verify against the position. So that way, we will not be checking whether against a Boolean, but instead we will be conditioning to certain value on position. So in this case, we will do something very similar. Let's say filter by position. We say this text position. It returns again an array of employees. We create the resulting empty filter array. So we say filtered employees. We don't know exactly what we're filtering against because this is actually something we're taking as parameter here. And then finally, we return the filtered employees after we do the actual filter here. So let's explore a little bit this structure because we have been writing a lot of functions, but sorry about that. This is actually leveraging exactly what the functions have to offer. Functions are blocks of actions that will allow you to perform certain process within your app. So those actions usually have an input, a process, and an output. So whenever we create a function, like filter by, for example, this will have something called the signature, which means it has a name, it has a list of inputs. In this case, it's only one, a position. And then it also has the type of the output, which is an array of employees. So this is the return type, the output. These are the parameters, the input. And the body of the function represents the process that will allow that to happen, to do whatever we need to do with that input in order to process and calculate the output. So this is actually the regular way usually programming languages work, and this is the way Swift does it. It's actually very similar to other languages like JavaScript, C#, Java. So it may be very familiar to you guys. Maybe there are certain differences, like for example, how we're handling the types afterwards instead of before against languages like Java or C#. And the return type is actually represented with an arrow, and then you state the return type. And then let's talk about the body. This is actually very similar to the filtering we're doing here. So we can actually paste it. Then there's actually a difference. We will not ask whether this employee is a contractor, but we will ask whether the position of that employee is equal to the position we want to filter. And that way, we just complete the function, except for we are using the contractors right here. So it's actually called now filtered employees. And again, just like a simple filter function, this is all it does. Just iterating across all the employees, asking whether the position matches what we're looking for using the input here. And then we append the employee to the filter employees if it satisfies the position, so that in the end, we just return the resulting filter array that we created empty in the very beginning. So this is all it does. So lastly, let's talk about how we can actually create a function that can mutate the values. Because actually, if you think about it, all we're doing here is reading values, but we are not really changing anything. We're not changing any of the employees here. What if we want to represent the operation that handles the promotion? What if certain employee is getting the promotion? So we may have a function that says promote employee with identifier ID. This takes a UUID that will represent the identifier. And we say, okay, we are promoting employee to exactly what position. So we need to take a position as parameter. And this will return nothing because we are not expecting this to have any output. We are just expecting this to use these inputs in order to mutate certain values within the scope. And then that's it. That's all it does. So basically, the first thing we're going to do is find exactly what employee matches with this ID so that we can update its position. So what we can do is say, okay, we have an array of employees available here because we have it here as a property. Then we can say first where, and we can have something called a closure. So a closure is basically an anonymous function that will allow us to state certain behavior that can be used by someone else. In this case, we are going to pass this closure so that we can use it in order to determine what employee matches what we're looking for. In this case, we're going to say employee in employee.id equals. So what we're doing here, we're passing the closure that basically takes one parameter called employee, and it will return whether the ID we're looking for matches with the employee what we're iterating on this first operation. So this is actually one of the functions that Foundation offers for us when handling arrays. And actually, this may be a little bit confusing, so let's actually put it in a different way. We are actually returning here. And as I said before, this is a function that is an employee returns a boolean. So this is actually the complete signature of a closure. We're saying, okay, this is a function that uses an employee, returns a value, and it will say whether the ID matches what we're looking for. So that way, that closure can be used by this first operation to determine what is the first one that will match and say true to this function, to this closure. And then the first one that has this closure return true is going to be the one that is going to be returned by this first. And this first is actually going to be assigned to the found employee here. Next, what we can do, that this is actually a var, this can be a let because we're about to mutate it. And then what we're going to say is, okay, found employee dot position is going to be updated to this new position. Or to make the code more readable, we can rename this to new position. And then it's saying, okay, we cannot update the position because it's a less constant. What this is actually a design flow, because position should never be a let. This is actually meant to change over time, because employee may have a great performance and maybe it can be promoted. So it actually should be a var. In that way, it would allow us to update the position with the new position. So here we have, this is the function that will allow us to find an employee and update its position in order to handle the concept of a promotion. Okay, so let's go with common existing functions. So let's refactor a little bit all this code, because this is actually something we can greatly improve by leveraging some of the functions that Foundation, this framework that we are importing here, offer for us. So we are using something called an array, which come from this Foundation. And if at any point the code will reference these employees and say dot, we can actually see that other than the basic ones that we already know, like appending for adding more values, and the first, which we already used, it also has some other operations like insert, move, distance for index, but it also has something called map, which is something very useful. Last, filter, which interestingly is exactly what we're doing here, compact map, flat map, and some more others that we'll actually take a full class to talk about. But we are actually doing something that is already handled by Foundation called filter. And that means we can actually go ahead and refactor this functionality here by just saying, okay, we want contractors to be employees.filter. And basically we can pass a closure just like before and say, okay, return this whenever the employee is contractor. And basically, I don't have to do this anymore because contractor is already being updated by this filter operation. This filter operation will use this closure to determine which one returns true on this closure. And basically, every single one that satisfies a true in this case will be appended to the result of this filter and return and assign to these contractors. So that means we can just get rid of this. And this is our function, way shorter, right? But now we can say, okay, I don't actually want to initialize it here right away and say, okay, var contractors is equal to this. Okay, Luis, go ahead, sorry.
Yeah, the question that I have is that those functions that are in the foundation for this example in array, I assume that they don't modify the original array and a new one, right?
No, they don't, but we are actually doing that manually. I mean, right now we are not mutating anything. We are just like getting the result of filtering the operation, but this is not actually mutating the original array, right? This is just like running the filter operation, returning a value for us, and we can assign it to another variable and do whatever we want to do with it. But if we wanted to modify it, we could just do employees equals to this, and that's it. We are mutating it right away. Make sense? Luis?
No, it's okay. It's okay. Sorry.
Okay, got it. Awesome. Okay, so now we have decreased this function to basically have 2 lines, but we could actually even make it even shorter and say, okay, we just want to return this right away. And that's it. We have only 1 line. But this line actually still looks a bit long. We could actually say, okay, I want to use something called the shorthand operator. And since we are only taking 1 parameter, we can just say $0, and this is taking the first parameter that it's been entered into this closure, and we're just using it, and that's it. And it's way shorter. And since this is taking a closure, I can just remove the parentheses. And it's even way shorter. But since this function is actually just returning something right away, we can just say this. And this is it. We have literally reduced all the functionality, or the long functionality that we have written before that had like a little bit about how many lines, 10 lines to 1 line. And it's just very simple. We're just filtering the array of employees to find wherever employee is a contractor. And we are satisfying the need of the contractors. And this is it. Now we're going to do the same with this. We're going to say, okay, let's return, no, not return, just like this, employees.filter, and say this is a shorthand operator where position is the position we're looking for. And that's it. We are filtering all the employees that satisfy this condition. But let's actually fix this here as well, the promote employee. We can go ahead and say, okay, we have this first, but we are using this closure, long closure here. We can just remove the type that is really implicit because Swift is in the third language. We can remove this because it knows it's expecting the Boolean. We can remove the parentheses. We have something very similar to what we had before on the filter functions. Now, let's remove the parentheses and the where, because this is just taking a single closure, so it doesn't need anything else. Now, let's use the shorthand operator that we just started using and say, okay, this is taking the first parameter to find where we satisfy the ID. So this is way better. I am finding employee by just saying, okay, find the first one where the ID satisfies the ID I'm looking for whenever it matches. And that's it. And actually, I can go ahead and instead of having this be 2 lines, I can say, okay, go and modify directly. Can I do this actually? Function called returns immutable value. So the problem here is this doesn't know whether this is a mutable or immutable value. So we can actually do this here. We need to state, okay, this is a found employee that we are modifying, and we are saying this is a bar, but this is actually a copy of this. So whenever we are updating the position, it will let us because it's a variable. But if we do this, what we are trying to accomplish, it won't let us because employees is actually an array, a constant array of employees. So it won't allow us to modify one of the inner employees, but that's exactly what we need anyway. So we should probably change this to var because employees are meant to change over time. So, and in this case, this is an optional because it may not find anyone that matches the position. Let's say that less. Sometimes Xcode is a little bit slow. So cannot assign to property function call returns immutable value. Yeah, I think this is actually because the first is actually returning a let value. It doesn't know whether it's meant to change or not because it's just something being returned. But in this case, we can continue doing this. And that you satisfy our need. We're just updating the position of the employee we just found. And this is actually an optional because it doesn't know whether it's going to find something or not. So that's why we have a question mark here. We say, okay, we're going to update the position of the found employee to this new position. And again, we have really decreased the amount of lines that takes completing this functionality. And finally, computer properties. So computer properties are actually a way to handle things that are not really meant to be functions, but are not meant to be variables either, because they take certain amount of processing. So for example, this result position name that it returns a string and doesn't take any parameter should actually become a computer property. And since it's going to become a property, now it can take the name of a property, like position name. We can just say this position name is a string. Basically, it will return the result position name of the position. This is a variable. Basically, the computer properties are just properties that have a body that will allow us to say exactly what it should do in order to return a value for that property. So that's actually why they're called computer properties. They're just like properties that are calculated on runtime, and they are not actually being stored. There are actually two kinds of properties: store properties and computed properties on Swift. All of these are store properties because are actually being stored in memory, but these ones are being calculated, which is why they're called computed properties. In this case, position should actually also be a computed property. And that means we can return the position name. This is actually a bit redundant, right? Position.position name, so we can actually change it to name and say name here. Right? So that's what computed properties is about, but let's actually go with a more complex example of this. In this case, we have the years in company, but as I mentioned before, we could actually have something called start date. And this start date will allow us to calculate the years in company. So that way, these years in company can be a computer property that basically will calculate using the start date and the current date, how many years have passed since the employee joined the company. So what we're going to do is calculate this by using something called the calendar, which is other of the constructs, not constructs, but symbols that Foundation offers, and we can just use to handle and calculate things with dates. So let's say the current date, which is date, we can say there's something called H components that basically will say calendar.current. We're using the current calendar, which is the Gregorian one, and we are going to calculate the date components, exactly what date components, years, that's what we're interested in, from our date to current date. And basically now we are going to return H components dot year. It's optional because it doesn't know whether it calculated the year or not. Since we already know it did, we can't explicitly force unwrap this value to a non-unique value. This is a terrible practice. Don't do. Never do this. What's the best practice here? Okay, have this be optional and have someone else take the responsibility of this optionality. But since we are actually offering years in company, and since this H component won't return anything if this is optional, we can say, okay, this returns here. So this is actually way better because this will give us certainty that the app won't crash because of this operation. If we did that as we did before, we are actually exposing our app to crash at certain times. We know this is not going to crash because we are just calculating the year, so we always return the H component for year, but we never know. Like someone may change the code and make the application crash, so we better go safe. Okay, and this is it. We are already calculating the years in company through a computer property and by leveraging something that is meant to be static constant called start date. which makes more sense, which actually will allow us to calculate the age of the user as well. We can say, okay, we want to calculate the age of that employee, and say we want to calculate it with the birth date. And that's it. We are returning the age of the employee as well. So this is what computed properties are about. And this is it, guys. Please, this is the space if you have any questions or comments, and that was the agenda for today. Go ahead, Robert.
Yeah, I just saw that you have structs and you have classes. Both can have functions here. So what will be the big difference here? Only that classes have initializers?
No, there are actually big differences between structs and classes. Structs are actually manipulated as values, whether classes are used as references. So that's actually a very strong difference, because whenever
Passes value and pass by reference. Okay.
yeah, exactly. So that's actually the most important difference. Structs are usually very strict when it comes to mutability. So if we are going to change the position, we need to make, let's say we're going to update the position here with a function, update position to position P. And we are going to say position is actually going to be P now. This is actually going to say, okay, position is immutable. Despite this is actually a var, so it shouldn't be immutable. So that's weird, right? Well, the reason is because this function is actually being called by someone who doesn't know whether this employee is mutable or not. So we have to say this function is mutating function that will update something with stored properties of the employee. So whenever we are going to use this function outside, we need to make sure that the instance of the employee is a variable instead of the constant, because we are calling the function. So basically, this is like a mark that we say, okay, we are updating the position, we're updating something within the struct, and hence this instance should be variable and not constant. That's basically what it's about. It's about mutability against immutability, and classes really don't have this restriction. With classes, you don't have to use mutating. You can just update everything because everything is being handled by reference. Hence, the strictness when it comes to mutability is not so strong. Those are the main differences. And usually that's the reason why structs are the most common way to represent structured data. But if you want to represent basically managers, coordinators, or just like pieces of functionality, just use classes, because you're not trying to represent data, you're trying to represent functionality, behavior, and basically determine what your app will be doing in certain moments in time. So classes are more common for that. The structs are more common for data types, which is actually very similar to data types in Kotlin. Yep. Did that answer your question, Roberto?
I think so, yes.
Any other question? Oh, go ahead, Luis.
Yeah, I have a question with the promote function inside the class. What will happen? How will be handled if the employee is not found? It will trigger a throw or something there?
Okay, yeah, that's actually a great question. So we are actually handling optionality here, but carelessly, because if we don't find any employee, we'll just not do anything because it didn't find it. But we should probably have this throw something, or say, okay, there was an error. So we actually have something called the guards. You can say, guard found employee, else do something else, and we say, okay, if you found the employee, it will update the position. Otherwise, we can print employee not found. Try another ID. So there are actually two ways we can handle this here with guards or with ifs. Guards are actually something offered by Swift because it allows us to emphasize the positive flow of our function. The positive flow of our function is the success flow, which is, okay, we are going to promote the found employee. So we are assuming we are going to find the employee. In this case, we are just saying, make sure the employee is found and do this. Otherwise, do this. But this is actually the negative flow. So that's why it's called with another routine, another block. And in this case, actually, we have an issue here. Okay, anonymous closure not content. Okay, this is actually complaining because it may confuse the brackets with the brackets of the guard. So it suggests us to use the parentheses instead. Not instead, but complementary to it. And that will fix the issue. That should fix the issue. Missing argument where, because we're missing the where. When we're using the parentheses, we need to pass the argument labels. Yeah. And that's it. So we can just do this. If we want to have the function throw an error, we can say, okay, this function actually throws. We are actually going to throw an error saying something. We can create a custom error here. Now, employee coordinator error and say case employee not found. And we can just return the function here, employee coordinator error dot employee not found. And that's it. Now we are leveraging, we are delegating the responsibility of handling this error to whatever piece of code uses this function. In this case, from expression doesn't conform to error. Oh, yeah, it doesn't conform to error, of course, because we have to extend from error here. Okay. And this is it. This is actually the way we handle errors, either throw them or handle them, whatever we want to do with them. Yeah, go ahead.
No. It was the thumbs up. Yeah, that answered my question.
Awesome. Perfect.
Yeah, one quick question. Classes here in Swift have you have constructors. Do you have the constructors?
Yeah, for sure. This is the constructor. This is called initializers here, and we're just taking the parameters and initializing the store properties, and it already does. And of course, they are mandatory. They're not mandatory. I mean, they're mandatory if you are not initializing right from here. But in this case, for example, structs don't have really the need of having you write initializers because they will create one for you.
Sorry, I was asking about deconstructors, as in
deconstructors.
the function that calls.
Yeah, for sure. You can actually use something called init, and you can do whatever you want to do here. So this is actually not commonly used because usually everything is discarded whenever the value of the type is discarded, because there's something very similar to garbage collection called automatic reference counting, ARC. So ARC will usually run this operation for you and discard everything, but this day init is offered for you in case you want to run certain operations at the moment of the initialization. Yeah, but yeah, this is the keyword you use in order to determine what to use whenever this is being deconstructed. Yeah. Is that what you were asking, Roberto?
Yes, that was what I was asking for. Thank you.
Awesome. Anything else? No? Okay, guys. So since there are no more questions or comments, this was the class for today. We will continue final class of Swift Primer next class. and then we'll start working on actual iOS development. So thank you for being here.